This is the second video on Chapter 12. It covers making confidence intervals for model values and for individual predictions and interpreting them. In video 1 for Chapter 12, we talked about calculating and interpreting confidence intervals for the model coefficients. And these types of intervals are of interest when the purpose of the model is describing relationships between the variables. In this video, we're going to look at confidence intervals for model values and individual predictions. And these types of intervals are of primary interest to us when the purpose of the model is for making predictions. These intervals will indicate the precision of our predictions. When we're making confidence intervals for a model value, what we're doing is we're creating a confidence interval that we are 95% confident includes the mean response, or the model value, given a set of values for the explanatory variables. So for example, if we were working with the Galton data, we could choose values for the explanatory variables. For instance, we could choose people who were male and whose mother's height was 67 inches and father's height was 69 inches. And then we could create a confidence interval that we're 95% confident includes the mean height among males whose mother's height was 67 inches and father's height was 69 inches. And give us our confidence interval here. And right now I have the confidence intervals given here. 69.85 up through 70.39 inches. We're going to see how to calculate those in R in just a few minutes. I can also make a confidence interval for an individual prediction. So to do this, it would be creating a prediction confidence interval, is what we call them, that includes the response for approximately 95% of individuals having a given set of values for the explanatory variables. So again, looking at the Galton data, I could choose the value of the covariate, male, mother's height 67, father's height 69, and create a prediction confidence interval that includes the height of approximately 95% of males whose mother's height was 67 inches and whose father's height was 69 inches during the late 19th century in England. And my prediction interval would be 70.13 plus or minus 4.24, which gives me a range of 65.89 inches up to 74.36 inches. And again, we'll see how to get those calculations out from R in just a few minutes. Comparing the confidence interval and the prediction interval that we made, we can see that the confidence interval is quite a lot narrower compared to the prediction interval. And they're interpreted differently. With the confidence interval, I'm 95% confident that the mean height among males whose mother's height was 67 inches and father's height was 69 inches was between 69.85 and 70.39 inches. For the prediction interval, approximately 95% of males whose mother's height was 67 inches and father's height was 69 inches were between 65.89 and 74.36 inches tall. So we have different intervals and different interpretations, and the prediction interval is clearly much wider. So why are the individual prediction intervals wider compared to the confidence intervals? The variance of the model value, given that I have chosen fixed values, little x1, little x2, up to little xm for my explanatory variables, can be written this way. Keep in mind that here it's the coefficients that are random. So I'm thinking about variability in these coefficients like I looked at in the last video. And because I've chosen values of x1, x2, and xm, those are actually constants. Now, if I look at the variance of individual values, individual values, remember, are the model values. Those are the same thing that I saw above, plus the residual. And what we see here is that I can sort of break this up into the two pieces where I have the variance of the model value plus the variance of the residual. And so the variance of the residuals here is being added to the variance of the model values. So there's a lot, well, depending on how large the variance of the residuals is, there may be a lot more variability among the individual values, but there'll always be at least some more variability among the individual values compared to the variability in the model values. When I'm using R to calculate confidence intervals and prediction intervals, I start by fitting my model using the LM, linear model function. Here I've got my Galton data. I'm using height as my response variable, and we have sex, mother's height, and father's height, all as explanatory variables in the model. After I've fit the model, I'm using this make fun function, which is essentially making a function that's going to evaluate fitted values for the model and also make confidence and prediction intervals for the value. So I have to give my function a name, my make fun, and I'm calling it f. So now I'm using this new f function that I made, and what I put in is I put in the values of the explanatory variables, and those are the same variables that I had to put in here to make my model. And then I'm telling it whether I want a confidence interval, that would be for the mean or for the model value, right? Or if I want a prediction interval for the individual values. You can see that once I use this f function that I made, it's going to tell me the fitted value, and that's going to be the same regardless of whether I'm making a confidence interval or prediction interval. And then it's going to give me the lower and upper limits here for a confidence interval, and then here for the prediction interval. So the things that you want to do before Thursday: first of all, you want to make sure you've watched the videos, which presumably, since you've reached this point, you have. The other things you want to do are to complete the Chapter 12 practice exercises as best you can, and get a good start and complete homework 7, which is due Thursday night, as best you can. And then be prepared to ask questions about the homework, course material, and practice exercises at Thursday's live meeting. Have a good day.